Okay, so our first section we'll look at this week is on solving multi-step inequalities. And I think what will help us to do this is if we can remember how to do multi-step equations. Okay, so we had a way to remember how to solve multi-step equations. Anybody remember the word? Or it was like the 3 letters that we use, not PEMDAS, that's for arithmetic, but this is for equations. Yep.
Sam.
Yep. So we remembered it with SAM. And on your note sheet, okay, so you should write this in. Leave a little space, because we're going to try to write 2 things under the simplify step. That was going to be my next question. I just told you the answer. I'll ask you the other ones. So S stands for simplify. Okay, there's 2 things I need to do under simplify. Does anybody remember the first one? Yeah?
Combine like terms.
Okay, I like that one, combine like terms. I'm going to put that as the second one. Or if you want to abbreviate CLT, combine like terms. And what do we have to do first? It doesn't always come up. Sometimes it comes up. It has to do with parentheses. Josh? The distributive property. Okay, so everyone should be writing those 2 steps down under simplify. Okay, distributive property and combine like terms. All right, so that's our first step. How about the A in SAM? Okay, addition or what else? Subtraction. So, okay, so under the A step, that's when we have to do any adding or subtracting. And that's the same thing we're going to do when we solve multi-step inequalities. Okay, we'll do our simplify, then we'll do our adding and subtracting. And then the very last thing we always do, okay, that's the M step. Multiply or divide. Yep. Okay, the only thing that's different about the multiply and divide step when you solve an inequality is maybe you have to flip it. Okay, so we'll talk again about that rule. Okay, so any questions on those steps? If you ever forget them, just try to think of that word, SAM. Okay? And that's your simplify, add and subtract, and then lastly multiply and divide. Okay, so you guys did pretty good with this earlier. I think we already should know the answer to this. But it says, what do we need to do if we multiply or divide both sides of the inequality by a negative? How about Dominic? Can you tell me what I got to do? If you multiply or divide both sides by a negative, what happens to your inequality? So not positive or negative. It has to do with the sign, like the symbol. Like what did we do when we looked at, not this one, but this one? What did we have to do because we divided both sides by a negative right there? Sure? Anyone help them out? Yeah, Shannon?
You flip the sign.
Right. Okay, when you divide both sides by a negative, you've got to take that sign and flip it. Okay? If you don't, usually you don't know that you did something wrong. It's till I look at it. Okay, it's not like you're going to get some kind of error on your calculator or something weird's going to happen. It's just going to come out wrong, right? So you have to remember that step. So flip the sign. Okay, so on your notes, under where it says, what do we need to do if we multiply or divide both sides by a negative? Just write in flip the sign. When else do we have to flip the sign? We don't have to, but we do this sometimes because we want it in a certain way. I can't really tell you too much more. Kyle?
When the variable comes first.
Actually, when the variable comes first, that's what we want.
The other number comes first.
Right, when we get something like this, do we like to leave our answer like that? No. Why not? It's not that it's wrong, but what don't we like about it? Because it could be confusing. Yeah, Antonio?
You want the variable on the left side?
Yeah, we do. Well, how come? Why is it better that way?
So when you're graphing it, it tells you which way to draw your arrow.
Exactly. Okay, if you leave your final answer like this tells you the wrong way to shade. So sometimes we have to flip around our inequality. So the variable's on the left and the number is on the right. And if we do that, we also have to flip the sign. Okay, that's a totally separate flipping of the sign than dividing by a negative. Okay, but I just want you to remember that one too. So anytime we get a variable on the right, we got to fix it so it's on the left. Okay, any questions on that? All right, so let's try our first example. Good, so they want us to solve and graph. Okay, so as I start to solve this in my head, I'm going to think of those steps. Sam. Okay, and like mentally, I'm going to kind of check them off as I go. Okay, so I start with simplify. Do I have, Natalie, do I have a distributive property here? No, nope, no distributive property. What symbol would you have to have, and that would tell you it's a distributive property? Yep, if you've got parentheses, that's usually going to tell you you have distributive property. Okay, so don't worry about that. How about combine like terms? Ashley? No. So I don't have to do the S step. Okay, I can go right to the next step, which is adding or subtracting. Okay, my goal is, what am I trying to get by itself? Yep, trying to get that by itself. So everything I didn't circle on this side, we want to put on the other side. Is there any adding or subtracting that would help me to get y by itself here? Oh, Aiden?
Wouldn't you have to times -6 by...
So careful, we're still on that step right there.
So you're going to have to -7
Exactly.
both sides.
I like the idea of multiplying, but we're gonna get to that in just a second. I'll come back to you if you want me to for that one. But first step, set it perfect. Going to subtract 7 from both sides. +7 minus 7, that's going to cancel out. I get y divided by -6. And can you go ahead and tell me 9 minus 7?
2.
2. And how about, Hannah, should I flip my sign? No. We don't ever flip the sign when we do subtraction. Okay, not till we get to that last step do we need to think about maybe flipping the sign. All right. Now, Aiden, you said something about multiplication earlier.
So you're going to need to times -6 by 6. And you're also going to need to times the 2 on the other side by 6.
So can you just tell me one more time what you want to multiply both sides by?
Oh, -6.
-6, yeah. Okay, so we're going to multiply by -6 and -6. And on this side, Sabrina, what's going to happen with the two -6s? Yeah, they're going to cancel out. And I get just y. Maggie, what's 2 times -6? Not sure. What if it was +6? What's 2 times +6? 12. Now this time, instead of a positive times a positive, we have a positive times a negative. So a positive times a negative gives you what kind of number? Yeah, good, negative. Okay, so you got 2 times -6 is -12. That's good. And the last thing I got to decide is if I should flip. What do you think, Marissa? Yes, why do you say yes? I agree with you.
You multiplied by a negative.
Yes, I multiplied by a negative. Okay, so that inequality should now point the other way. All right, did we do everything the directions asked for? No, what have I done so far? Yeah, go ahead. Yes, I solved it, but now I have to graph it. Okay, so on your notes, do you guys have a number line already there? Okay, hopefully I do somewhere. Okay, first thing I'm going to do is number my number line. So I'm going to put negative 12 in the middle. I'll put negative 13 and negative 11. Okay, as long as you put the number you're going to put a circle on and then put 1 on each side, that's one way you can do it. And Iseles, how about what kind of circle? Open or closed? Open. On what number? Perfect. Open on negative 12. And now I just need to decide if I'm going to shade left or shade right. The way I have this set up, is this set up the way we like it? It is. Variable on the left, number on the right. So can I go by the direction that's pointing? Yes, I can. Yep. So, Derek, which way am I going to shade from negative 12? Yep, I'm going to shade to the right. And that's it. Okay, so that's all there is to solving multi-step problems. Okay, we had to do a little subtraction and multiplication, two things in the same problem. Okay, but any questions on that? All right, so we're not going to graph all of them. You might, if you look ahead on like example 3 or example 4, it just says solve, and that's going to be the same way on the test. You don't always have to graph. Okay, we'll practice a couple. Okay, why don't you guys take a few minutes and try that one on your own. Okay, it's another 2-step problem. Okay, if you get stuck, think of those steps. So try to solve it, and then if you finish that, try to graph it too. I'll walk around and see how you guys are doing. All right, so Liam is going to show us how to do this one. So if I get this right this time. So as Liam writes it down, I'll just kind of say what's going on. I'll be the play-by-play commentator up here.
He's a big boy.
So we got, looks like he's adding 4 on the left and on the right. So far, that looks perfect. Canceled out the +4 and -4. And you flip the sign. I did. I think you did. Oh. Well, look at yours. Which way is yours pointing? Oh, no, you didn't. I'm sorry. That's me. No. Don't listen to me. Nope. Kept the sign the same. Perfect. Yes, he's got v is greater than or equal to 6. Perfect. If you scroll down a little bit. Oh, you're not done here.
I'm not.
Now we got the number line.
Oh, okay.
So now we got to graph it. So we numbered it. Perfect. Again, on the test, a lot of the times the number line will be labeled for you. But if it's not, you just got to fill in your numbers.
Oh, good job.
Perfect. Okay, how many people had v is greater than or equal to 6? That's it.
Oh,
Okay. Any questions, or did anybody do anything different on that one? Okay. So good with number 2? Perfect. All right. Let's take a look at number 3. What's a little different about this one compared to? Let me put the last one up for a second. We had that one. And then the first one we had was right there. Anybody see what's different about this one?
The action.
Okay.
There's two
Like
like
jump.
There's two what?
there's two like terms on there.
And well, where are they now?
On
Opposite.
They're on different sides. Okay, so the key this time is now we've got variables on both sides. We have a side we always like to get the variable on. Okay, that's the way I would probably do it. Okay, and what side do we always like the variable on?
the left.
On the left. Okay, this one we are not going to graph. Okay, we'll just solve it, and that's it. Now, if you don't want to get the variable on the left, you don't have to, but then in the very end, you're going to have to flip it. Okay, so I think it's easier to get it on the left first, and then you don't have to flip it in the end. All right, how about, Katie, could you tell me my first step here? And keep in mind the goal is we're going to try to get all the variables on the left. All right, so you want to do something with that 2x? You want to move it, which way do you want to move it to? Yeah, we're going to move it to the left. So how would you move it?
Negative 2x under, yeah, negative 2x under that. And then under the 6x.
Yep. So she's going to subtract the 2x from each side, which is perfect. What else could you have done first that would have been okay? Since we didn't do what I'm thinking of first, we're going to have to do it next. But it doesn't really matter which one you do first. Yeah, Antonio?
First I did 5 plus 5 and then 5 plus 11.
So you did a plus 5 on each side? Yep, that's okay. You're either going to do that step first or this step first. But you're going to have to end up subtracting 2x and doing a plus 5. So we'll do this one first.
What if I did both of them? Like if I subtracted 2x and then I added 5 from both?
You could do both in the same step if you want. Okay, I'm not going to write it like that this time because it might confuse people. But if you did both in the same step, as long as you did it right, that's okay. Yep. So 2x minus 2x is gone. Vanessa, what's 6x take away 2x? 4x. Anything else still left on this side? Minus how much? Yep. And I have an 11. Let's see, do I flip the sign? No. No, don't flip it this time because we get that. We didn't divide or multiply by a negative. Okay? We subtracted, but we didn't divide or multiply. All right, the next step, Antonio, I think you already told me. What did you do?
I did 5 plus 5 on both sides.
Plus 5 on both sides. Okay, so now we've got that. Side, what's going to be on the left-hand side now?
4x. Oh, yes.
What's going to be on the left-hand side? Yep, and how about on the right-hand side? What's 11 plus 5? Good, 16. And how about Emma? Should I flip?
No.
No. Didn't multiply or divide by a negative. All I did was add 5. Okay, so we took this problem, which was originally, this was called a 3-step problem. Then at this point, it was a 2-step, and this is just like the ones we did in example 1 and 2. Now this is just like the ones you guys did last week. 1 step left. Okay, what's my final step? Ashley? I'm going to divide both sides by 4. What kind of 4 did you divide by? Positive or negative? Positive. So should I flip? No. So I get x is b. How do you pronounce that one?
Less than.
Perfect. X is less than. And can you tell me what 16 divided by 4 is?
4.
Yeah, good job. X is less than 4. Okay, do we have to graph it?
No.
Nope, the directions didn't say to graph it. It just said solve. So we don't need to graph. And again, most of the time when you do need to graph it on the test, what am I already going to put there for you anyway? I'm going to put the graph and put the number line for you. Cool. Any questions on that? Anybody think they need to see another one just like that, or are we ready for example 4? You ready, Jordy? Jordy's ready. Everybody else ready? Siri's ready. All right, so this one's a little different. Okay, it does have the variables on both sides. But this is what we call it. This is going to be a special case. Okay, what is going to happen here doesn't happen a lot, but it does in this problem. Does anybody know why this one is going to be special? Part of it is because it has variables on both sides, but it's not just the variable. Look at the number in front of it. Yep.
Because the number hooked up to the variable is the same.
Right, when the number is the same on each side, okay, something special happens. Okay? Let's start to solve it just like we normally would, and we'll see what happens. Josh, what were you going to say? All right, so let's put everything on the left. Okay. So I'm going to move that negative 6x to the other side. And how would I cancel out negative 6x? And move it to the other side. Marissa? Yep, we would add 6x. And where else do I have to do it? On the other side. Okay, but watch what's about to happen. Aiden, what's negative 6x plus 6x?
It cancels each other out.
Cancels out. So what's negative 6x plus 6x?
Cancels each other out.
Okay, that usually doesn't happen, but it did here. Okay? So what happened to all my x's? They're all gone. Okay? Bye-bye. What's on the left-hand side now? Just an 8. What's on the right-hand side? A negative 3. And I have this inequality, which I do not need to flip. What does that say if you read that? 8 is greater than negative 3. Okay, does that make sense? Is that true? Yeah. A positive number is always bigger than a negative. Okay, that's a true statement. So, anybody know what the answer is going to be? It's not true. Anybody think? Okay, it could be any answer. Does anyone remember how we write that? Sometimes we write 3 words. Begins with all. Yeah.
All solution. All, we used to call it no solution or.
Well, we might see a no solution, but this one's not a no solution. This one is anything can be a solution. So I would accept if you wrote anything can be a solution, or there's another phrase you can say that begins with the word all. Josh? Yeah, you could say all numbers, yeah, or all real numbers. That's what I was thinking of, but maybe it's easier just to say all numbers. Okay, the only thing I won't accept is if you write true. Okay, true isn't the answer. This statement is true, which means this. All numbers. Okay? So the way you can tell when you have a special case is you have variables on each side, and the number in front is the same. Okay? This is one thing that could happen. You could get any number as a solution. Anybody think they know what else could happen besides anything being a solution? What's the opposite of everything being a solution? Nothing being a solution. Okay, so I'm going to have you guys try this one. Okay, you should be able to tell quickly if it's a special case, if you've got a letter on each side and the number in front of each letter is the same. Now, don't copy what I'm about to write, but if I did this, that's no longer a special case. One's a positive 5, one's a negative 5. That's totally different. That's a special case. Okay, so take a minute. If you're not sure what happens, that's okay. We'll go over it together, but just try to do what you can, pretty much like we did in the last one. Just try to at least do the first step. All right, so what would be my, my first step to get all my x's on the left? You want to write it? Sure.
Can I do it all out?
You can do it out, yeah.
I just wanted to make sure. I still don't like these boards. Nope.
Oh my god, it's fine.
They can put some other marker down in this.
You sure we should do it? It's plugged in. No. No.
So it looks like she's doing something with, can you write down, what are you doing, Cindy? Are you adding or subtracting?
I'm about to put the sign.
Perfect.
I normally do it after.
That's okay. As long as you put it, that's fine. Okay, so she subtracted 5x from both sides, and it looks like it canceled out both at the same time.
And
So yep, the 5x's cancel out, and you're left with zeros. So we have 8 is less than or equal to,
-9, is that a negative?
that is a negative 9, yep.
I was just,
All right, so now you just got to write down your answer. And make sure we put the colors in. Wait, so what's your final answer, Si?
Or solution.
no, oh,
So we got a statement there. Is that true? Is 8 less than -9?
No.
Or less than or equal? No.
It's not true.
So it's no
you
solution.
just don't like this.
It's not true. So, Jordy, what did you just say?
No solution.
No solution. Perfect. Okay, so that's the second special case.
Yeah, you can't write this one line. No, so,
It's
S-O-O-L-U-T. I feel stupid.
No, that's okay. You're doing fine.
S-O-L-U-T-I-O-N. I feel stupid.
No, you're doing great.
That's okay.
Perfect.
Oh, it's a nice hammer.
I used to spell it as.
You got it right. Good job. Okay, so no solution. On the test, okay, I'm not going to give you probably more than one special case, because a special case, I can't really tell if you know how to graph or solve it, because you basically do one step and then you're done. Right? There's nothing to graph here. So I'm going to give you ones that most of them you'll be able to do. If there's one special case, I'll let you know on Thursday, because I don't have your test yet. Also, there'll probably be a review guide on the Google Classroom this week too. Okay, I'll try to do that. If Mr. Roy's coming back Wednesday, I'll have a little extra time to get that done. Okay, so any questions on that one?
No. Break time.
Break time? We got one more problem and then we're done. Can you hang in there one more?
Yes.
Yeah. All right, so this problem says you need a mean score. What's mean mean? It's the average, right? Just a way to say average. So you need an average score of at least
I never
90.
liked doing these.
What does at least mean? A couple people got this mixed up on the test. Like if I said to you, I have at least $20. That means I have $20 or,
Less.
No,
more.
like if I said you have to be at least 18 to vote.
You can still be 18 or older.
18 or higher, older, right? So when you see the phrase at least, that means that number or higher, right? So this problem says that to go to the next round in this trivia game, you need a score of 90 or higher, okay? So let's write that down. Okay? We want the average score. So what inequality symbol is that? 90 or higher. Right, I want the average score to be greater than or equal to 90. Okay? That's what I need to figure out. As long as my average score is greater than or equal to 90, then I go to the next round. So here's what you've scored so far. Okay, round 1, you got a 95. then a 91, 77, and 89. Okay? I have to figure out, what do we have to score in the 5th round to make sure we can advance? Okay. So, first thing I have to figure out is this. My average score. How do you find an average? What do you do? Well, it's actually 2 steps. You're going to take all the things you have and do what with them? Josh? Okay, let me start with that. Take all my scores I have, 95, 91, 77, 89. Now, what should I put for my score for the 5th round? I don't know it yet.
X.
Yeah, so let's just put X. Okay, so I'm going to add up all 5 scores, even the one I don't know. Now, is that your average? You just add everything up?
No, then you divide by how many there is.
And you have to divide by how many you have. Okay? How many different scores do I have? 5. That's my average score. And I want that score to be greater than or equal to what number? 90. Okay. So we're going to use our calculator to help us out here. But what should I do first in this numerator? Yeah, why don't we just add up all those numbers so that way we can just combine it. So 95, got 91, 77.
This is going to take a while.
Oh, that's it, we're done. So it adds up to 352. Okay, this one is just like some of the other inequalities we've done before. Okay, I don't like having this fraction here. So if I can get rid of this 5, that would be perfect. Does anybody remember how we can get rid of this divided by 5? And whatever we do to get rid of it here, we got to also do on the other side. Josh?
Multiply 5.
Perfect. Multiply this side by 5, and that side by 5. And what happens to the 5s, Josh? Yep, these cancel out. So now we've got 352 plus x. Should I flip my inequality, Ashley?
Yeah,
Why?
because the X, it turned out weird.
It would turn out weird.
Yeah, like the thing, I don't know.
What's the rule? When do you flip it?
When it's a negative.
When you multiply by a negative.
Yeah.
But what number did I multiply by?
Just kidding.
Yeah,
Just kidding.
just a positive 5. So, are we going to flip it?
No.
No. Okay, and how about 90 times 5? Or if you're not sure, I think of 9 times 5. That is 0. 450. Okay, I've got one step left to get x by itself. So this is a positive 352. How do you move a positive 352 to the other side? Not divide. Divide as if you had something like this, Jordy.
Subtraction.
That would be division. But in this case, somebody just said it. Subtraction. Yep. So minus 352 and minus 352. Okay, so that means my score, okay, x is the score in the 5th round, has to be greater than or equal to, now I need to do 450 minus 352.
102.
Close, you just add 2 the wrong way, so it's not 98. So that means my score has to be what in the 5th round? How would you say that? My score has to be at least 98. Okay, at least 98, and I will go to the next round. Okay, any questions on that one?
Something weird about me is if my penmanship is nice, no matter how hard I look at it, I can't cross it out. I'm trying.
All right, so what we got to do, we got about 20 minutes left.
Break.
I'm going to give you break. You need a break?
Yes.
Well, you can work on that individually. You take a minute break, relax. Try these three.
Wait, do we have
Okay.
homework?
And then once you finish up those, if you finish them, I'll give you the homework.
No.
Alright,
Okay,
okay.
if we finish,
Have
I mean,
homework?
if we don't finish, we don't get homework.
Nope, then I give it to you as you walk out the door.
Have the homework?
Okay, so try those examples, and then I'll give you guys the homework, which is worksheet on 2.4.
My